All right, so last month at Google I/O, Google Duplex demoed an amazing piece of AI technology that was able to effectively pass the Turing test. So by that I mean this AI was tasked with calling a local barbershop and a local restaurant. In both cases, the person on the opposite side of the line did not figure out that they were talking to an AI. So for my presentation today, I'm going to be covering the backbone of mind-blowing technologies like this, and that being natural language processing, or NLP for short. So natural language processing is a subfield of machine learning that focuses on the processing and analysis of natural language. So when I say NLP, you might think of things such as speech recognition or things like language translation. So I'm actually going to dive a bit more into the analysis part here, and I'm going to be focusing on a subfield of NLP called natural language understanding. And in particular, I'm going to put a lot of emphasis on the task of sentiment classification. So sentiment classification is the task of categorizing the opinions behind a given sentence. So let's take a simple example. I have 3 movie reviews. All right, so let's say I asked my AI to perform sentiment classification on these reviews. My AI would essentially be ranking these in terms of rating. So the first movie review, that movie was terrible, complete waste of time. My AI might see that it has one bad keyword and no good keywords. So as a result, it might give it a 1-star rating. The same logic would apply to the remaining sentences, where in the second review, 1 good and 1 bad keyword are both detected, so a 2-star rating. And so on and so forth for the third sentence. So I'm going to give a quick demo now about a sentiment classification that I built. Now, it doesn't follow the example I showed before, so it doesn't classify movie reviews by rating, but rather it detects the emotions and the context surrounding a sentence. So let's say I typed a sentence, I am very happy today, and I'll get a happy emoji. If I type in, I want to play sports, then I might get like a ball emoji. Or if I want to do like a double negative, so I am not happy today, I should get a sad face. So how can we approach the creation of models like this? Well, we might want to first look at something called an artificial neural network, or an ANN for short. So an ANN uses a training set of inputs and expected outputs. The neural network itself predicts an output and basically tries to minimize the difference between this predicted output and the expected output. So I take my inputs and I throw them into the input layer. These are then used to calculate the values for the next layer, which are called activations. The activations for the second layer are used to calculate the activations for the third layer, and so on and so forth. And we repeat this until we eventually get our predicted output. So once we get this predicted output, my ANN will compare the predicted output with the expected output, and it'll go through a process called back propagation, where it basically goes through my layers and it adjusts different variables so that on my next run of the neural network, my predicted output becomes slightly closer to my expected output. And I'll do this continually until I get an output that I want. So if we apply this model to sentiment classification, then we might get something like this. So as a collection of inputs, I have my sentence, so this is the greatest movie ever. And I run it through my neural network, and my outputs will be a probability distribution over 4 different categories. So let's say that my AI believes this sentence has a 50% chance of being category 4. But since this is a probability distribution, where the probabilities of all of the outputs add up to 1, then since 50% is the highest probability, my neural network will say, well, my predicted output for this sentence is going to be 4. So I have a movie review of 4. Now, there is a problem with this, though, because when we look at artificial neural networks, when we put in the input sentence, order is neglected. So what I mean by that is if we get a sentence like, that movie was not bad, as order is not considered, not is not considered to be immediately before bad. And as such, an AI might actually rate this to be a bad movie review. To fix this, we can use something called a recurrent neural network, or an RNN for short. This looks really complex, but it actually is really similar to a normal ANN. So it still uses the previous activation to calculate the next activation. But the main difference is that instead of just having all of my inputs put into this neural network at once, I'm putting them per every new activation. This effectively solves the ordering problem, as now the order in which I put my inputs into my neural network is now going to affect my future outputs. So with this, we've effectively solved our ordering problem. If we want to apply this to our sentiment classification task, then we would use a many-to-one model. And all this really means is that we take in inputs of variable length, but we only have one output. So a diagram like this would make sense. However, sequences are not our only problem when we look at NLP. And that's because we also have the problem of word representation. So usually when we input our words for the neural network, we express them as something called a one-hot encoding. So we basically create a list that has a length of the number of words that we want to account for. Every position on this list will correspond to a single word. And we can use this to distinguish between different words. So for example, position 1 might correspond to the word A. Position 2 might correspond to the word abbreviations. And we do this until we get to our final word. The problem with this, however, is that it doesn't really capture word meaning. And by that I mean, since it's just literally a list of zeros with a single one in it, it's very simplistic and doesn't really capture mathematical relationships between these words. And as a result, our neural network has these inputs and it can distinguish between them, but it's harder for it to actually process it and analyze it correctly. To fix this, however, we can use something called a word embedding. Now, word embedding essentially means the process of creating a word vector for every single word. In other words, every single word can be now represented by a point in space. So let's take the first figure as an example. Man, woman, king, and queen have all been turned into word vectors. Now, if we use linear algebra and subtract the word vectors of man and king, and then add the word vector of queen, we'll get a vector that is similar to the word vector of woman. Now, in doing this, we've just captured a gender relationship. So a multitude of relationships like this allow a word vector to actually have meaning relative to other words. And when we do this, the neural network can now pick up relationships between these words, so it can better process and analyze them. So how do we create these word vectors, though? When we start, we actually just randomly initialize all of our word vectors. So they're all just random points in space. However, we use another artificial neural network to actually train these word vectors into going to where they should go. And we select our training set like this. So given a sentence, I will select a random word as my input. So let's take the third line as my example. I select the word brown. Now, as my expected outputs, I select the neighboring words. Because if I select my training set like this, then my neural network will be able to figure out which words should or should not be together. And if we do this a bunch of times over a bunch of inputs, then we can effectively create these appropriate word vector relationships. So as we run through our artificial neural network, the word vectors will slowly move until they get into their appropriate positions. So with techniques like word embedding and RNNs, there are a lot of applications for NLP. And one of the most common might be like the virtual assistant. So either chatbot or some other kind of assistant, if we apply effective NLP algorithms in this situation, then my program will be able to better understand what the user will want. And this can be very helpful towards like improving user happiness with like a program and just the effectiveness of the program in general. But that's a very fundamental example. Let's jump one level higher and look at stock trading. So while this may not analyze the numerical basis behind all the stocks, we can use things like sentiment classification to generate a public opinion behind a stock. So let's say I select a bunch of news articles that are like live, like 20 minutes ago, that are currently surrounding a stock. If I apply sentiment analysis to all of them, then I can figure out whether or not the public opinion thinks like, oh, is the stock going to go up or is it going to go down? As an example. And if we take this one level even further, then we have something like summarization. And this is actually one of the hottest topics in NLP right now. So let's say I have a very complex scientific paper. It's very long, it has a lot of abbreviations, and the abstract is not great. It doesn't give me a good overview of what it's about. So using an NLP algorithm, I can actually summarize a long paper like this into just a few key lines. And that can be effective. That can be very effective towards saving the times of scientists and just anyone reading the paper. Now, this is a very specific example, but you can also use it for things like legal papers, where you want to like summarize any key points in there, or like insurance, or just any paperwork in general, where you want to get a very quick idea that's also very accurate. So I've only highlighted a few examples, but NLP applications are practically everywhere. Natural language is the way that we communicate, and all of our speech, all of our text, that's all natural language. So by developing NLP, we're effectively developing our interaction between humans and AI, and also just how effectively we can use AI as a whole. With this being said, and due to the general importance of natural language, NLP is going to be essential towards the future of AI development, and is going to be crucial towards the future of innovation. Thank you for listening. Turing test is basically a test developed by Alan Turing that tests whether or not like an AI is intelligent or not. It's a pretty outdated test, but the theory is like if you have an AI talk to a human being, if the human being can figure out that it's talking to an AI, then it failed the Turing test. If it cannot tell, then it passed the Turing test. So yeah, that's what the Turing test is.